So the unit that we're jumping into now is a unit on trigonometry, and this will be new for almost everyone, and most likely everyone. This is going to be new for you. And trigonometry is one of maybe the single most important thing that we learn in geometry. Not because when you get to be 30 years old, you're going to be using trigonometry every day, but you will run into trigonometry with all your future classes and math classes, that is, and it's so incredibly useful in the grand scheme of things. It intersects with all kinds of different sciences, technology, engineering, and so many people are using trigonometry in order to find out answers to questions. So I'm trying to think and talk at the same time, and that's never a good combination. So as we develop and understand trigonometry a little bit better, which we're not doing today, we're getting it set up, it's good to know just a little bit more about proportions and similar figures. So that what you're going to be doing today is you're going to have 3 problems each from all 3 of these levels. So I'm just going to run through this real quick. And what we've got is 2 similar triangles. And we talked about similarity a little bit. Similarity means that you have the same shape of a figure, but different sizes. And what that means is that all these angles are congruent. If this had been a regular school year, we would have spent a lot of time talking about similarity and developing a lot of ideas. And so the angles are all congruent from one shape to the other, but the side lengths are definitely different. Notice right here, this side length is 7 and this one's 31. So they're not congruent. Okay, so that's kind of one of the important things with similar figures. The other thing, because these sides are not congruent, what we know about them is that they grow proportionally. And by that I mean, let's pretend, I'm going to make this simple for this particular case. Let's say this is 14, not 31. So I go from 7 to 14. Obviously, I just multiplied by 2. Every single side will grow by the same factor, right? So this PO corresponds to SR. So the 17, when I bring it over here, is going to grow by the same factor of 2. 17 times 2 gives me 34. So proportionality means that everything grows by the same factor. And I've said that enough, so hopefully that's sinking in. And that's why we can set up a proportion, because we know that the proportion from 7 over 14 equals 17 over 34. And if I simplify that down, it's going to be 1 over 2 equals 1 over 2. Proportionally, they are the same. Obviously, the actual values are different, but the proportions and the ratios between the two will be equal. All right, I'm going to clear this out because we don't have that particular setup. Now, here's one of the things that we're going to be talking about today, which is dealing with how we set up our proportion. And if we were looking at this stuff before and we were setting up proportions when it came to the side splitter theorem, and there's a whole idea of the pattern of correspondence, right? So I can go from the short leg on this triangle to the short leg on the other triangle, and that would make it 7 over 31 equals, now the same pattern of correspondence would say take the longer leg of this triangle and correspond it to the longer leg of this triangle. So the same pattern of correspondence would make it 17 over x. And there's a proportion. Now, I'm not going to solve this just yet. I'm going to label this what we will call a between figure ratio. Now, I say between figure because notice right here, the 7 and 31, those are different values, the corresponding sides between 2 figures. All right, now I can compare that. I'm going to erase over here on the diagram, and I'm going to set up my proportion differently. Now I'm going to do 7 over 17 equals, well, I can set this up the same way. If this is x right here, I'm going to do 31 over x. And notice that, I mean, well, maybe you notice, maybe you don't, but let me assure you that the answer to either one of these proportions is the same, but in this case, we have what's called a within figure ratio, because both of these numbers for each ratio came within the same figure. Not ratio, not ration, it's ratio. Okay, so there it is. We have a between figure ratio and a within figure ratio. For practical purposes, as you're doing this homework tonight, it doesn't matter how you set it up. And I'll tell you that Delta Math will always set it up as a between figure ratio. But it's important to know that there's a distinction only as we're building up what it means for trigonometry. And once we get into trigonometry, we don't need to worry about it anymore either. But I think it's worth it just also to get some practice with this. So now we can actually solve one of these. And because what we want to focus on with trigonometry is the within figure ratio, I'm going to get rid of this one. And again, within figure means both these numbers for this came within the same figure.
So sorry, just pretend in here.
Okay. So let's look, that's the only level 1 type problem that you need to see. And you'll have 3 of those. And I think you'll probably be able to get those done. And if you run into problem, well, wait, I wanted to actually solve this. I forgot what we were doing. So if 7 over 17 equals 31 over x, and here's our unknown, and it tells us right here to find the side RS, so that's where we've got it. So now I can do my cross products. As a reminder, that's how we solve proportions. So I've got 17 times 31 equals 7 times x. And you can already tell from this that this is not going to be a very nice, easy, simple number. We're going to get some decimals. 17 times 31 is 527. 7x on the other side, I need to divide by 7 on both sides. And I get 75.2857 ... And notice how they want us to give an answer. It says round to the nearest tenth if necessary. Well, this will be necessary because we do have a decimal answer. And for some of you, you know how to round, and this is no problem, but I will say rounding errors cause a lot of problems in this. So what I've got is 75.285, and just to run through how we round, first of all, where are we rounding to? The tenths place. And the 10th is the very first decimal. All right, again, this is probably going to sound like elementary stuff, but again, I just see so many errors with this. All right, so the way we round is we look at the next number to the right. I don't care about any of these other numbers. The 5 and the 7 don't matter, only the next one. So now if it's 5 or greater, so greater than or equal to 5, we round up. If it's less than or equal to 4, we round down. So in this case, 8 is greater than or equal to 5. I'm going to round that up. It's going to be 75.3. The biggest thing people do is they don't bother looking at the next number. They just kind of cut it off. That's called truncating. If I just truncated this and called it 75.2, that's not rounded correctly. And that's what I see people do all the time. All right. So now we've got 75.3. Let me plug that in. I'm not going to explain rounding for every problem, but I do need to run through it. There it is. We've got it. You can run through the way that they do it, and they do use between figure ratios, meaning they're going to set it up as like right here, 7 over 31. You can see right there equals 17 over x. They set up their ratios between the two figures. We get the same answer regardless. Let me run back. Let's look at level 2. This is set up a little differently, and it looks weird at first because you see this animation going on. And this animation will just keep repeating, which might be distracting, but you can ignore it. So what's happening is that they're showing that these two these are triangles. Two triangles right here, they are similar to each other, but they've been rotated and dilated And this is something that we didn't get into in class that we would have done in a regular geometry year. We would have actually worked with dilations. That's where you make a shape bigger or smaller. And you can see the very first thing that's happening in this animation is that this first triangle is being dilated smaller, and then they rotate it, and then they slide it over, translate it. So it's a composition of transformations, right? And now we can see what corresponds to what. So this 19 right here corresponds to this side SQ. The 41, when we see that transformation happen, corresponds to the 14. It's a nice visual that shows you how these correspond. You might not need it. You might be able to tell right away, but still it's good to have it. So if I want to set up a proportion to solve for this, I just need to make sure I'm setting up the corresponding sides in a pattern of correspondence. So I'm going to make this a within figure ratio. So 19 over 41, notice I'm going from the smaller side to the bigger side here, equals, well, what corresponds here is my x's right here corresponds to the 14. So it's going to be x over 14. All right, any questions on that proportion? Is that what you got? Okay, so I'm not just going to run through them all individually. In fact, from here, I want you guys to find the answer. I'm not going to do the cross products for you. So as soon as you have an answer, feel free to write that on the screen. All right, so 6.5 is given. And sure enough, that's right. So again, okay, sorry about that. So I'm not going to run through the actual stuff there. Delta Math is great that it kind of walks through the steps for you. All right, I'm going to be done with level 2. So you're going to have 3 level 1 questions, 3 level 2, and 3 level 3. It really doesn't really step up in difficulty that much. So you should be able to just approach all of them the same way. But now they're not giving you any kind of an animation. They're asking you to figure out how to set up your proportion so that you can solve for the missing value x. All right, and now I'm not even going to set this up for you. I want someone out there who's feeling brave to go ahead, fill in our proportion with the correct ratios so that we can solve for the missing value x. So we have a proportion here that works. I saw someone else creating a proportion at the same time that looked different. But the important thing here is that the way that it was being set up the other way could have still worked. There's not just one way to set this up. And we already talked about that in the past, but I just want to reiterate that in this proportion right here, we have a 7 in the numerator. The other one that was being set up had 5 in the numerator. That's fine. If we flipped both these ratios, that's fine. It could be 5 over 7 equals 23 over x. And these are within figure ratios because notice I'm doing the 7, the longer side over the short one equals the longer side over the short one. And we need to visually be able to tell which sides correspond. And I should also add that these are not proportional. So these are just kind of generic triangles and they switch out the numbers. So the numbers won't necessarily correspond to what it appears to be, if that makes sense. So anyways, this proportion works. Go ahead and solve for the missing value. And in case you can't tell, that's the x right there. So I wanted to make sure everyone had time to run through this and do the calculations themselves. And hopefully everyone came up with 32.2 also. So as far as this goes, what am I trying to say here? Losing my train of thought. The number that we got was just straight up 32.2. This one worked out really nicely, but keep in mind you will have to round for a lot of these and make sure you're rounding correctly. I'll just type the answer in, 32.2. There it is. And we got the green check mark. We're good to go. I'm not going to look at anything else. I don't feel like we need to see any more of this. This is kind of review of stuff we've already done. So I'll just pull up a new problem. And as you're looking at this, if this is something that you have questions about, feel free to stick around. We can run through it. But if you feel like you have a handle, you look at this and you immediately know how you'd set up a proportion and solve for it, then you're good to go. And at this point, you have your homework is assigned to you on Delta Math. And bottom line, stick around if you have any questions. If you don't have any questions, you can have a wonderful day. And that's all I've got.